All right, welcome back, my friends. We're going to look at this lesson 2. This is a review of something you did in Algebra 1, inequalities, graphing those and solving them. Some things to kind of keep in mind when you have x less than, strictly less than a number, it means that you cannot have exactly that number of things. You can only have less than that. So if you can have less than 3 cookies, you can't actually have 3 cookies. So you have this open circle that we use. Same thing goes for x is greater than a number. I have an open circle at that number and then anything greater than that. So you can go, if it's greater than 4, it can be 4.01, but it can't be 4 because 4 is not greater than 4. So those symbols do open circles. When I swap and have or equals to at the bottom, now it can equal that number and then be less. Or here, it can be greater than or equal to that number. So it can go to the right and be filled in. Okay, so graphing, we're going to just do that. I personally don't have a lot of concern about how you draw these. I like to maybe mark 0. And then this one is greater than or equal to -1. So I'm going to have a solid circle filled in starting at -1. So I know I like to have it shown where you're starting, clearly show whether it's solid or open, and then an arrow in this case to the right because that's where the numbers that are greater than that would be. Versus here where this is strictly less than. So again, if this is my 0, 2 would be here. I'm going to write 2, and then I'm going to leave it open because it has to be strictly less than that, and it's going to go down to the left from there. So this is something you did before too. This is a between, x is in between. We call these an and statement because you can see here it has to be greater than -1 and also less than 2. I think of them as between statements because that's what it is. It has to be between those two values. So here, if I throw down a 0, notice these are both strictly less than or greater than symbols. There's not an or equals. So both of these are going to generate open circles rather than closed. So at -1, open circle. At 2, open circle. And I am everything in between. And so I'm going to just draw a little line in there. So it's kind of like a little line segment for everything from -1 up to, but not including, in this case, 2. This says or. You cannot have an or statement without saying or. And I always think of them as oars on a boat because most of the time, these are going to go off to the side like oars on a boat would. So you end up doing just 2 separate... I'm watching my puppy. Yeah, gotta go. Okay, so where was I? I am going to go ahead and draw each piece of this. So if this is my 0, I want to draw the x is less than or equal to, which is going to generate a filled in circle at -2. And then less than is going to go off to the left. Whereas the second part, or, because it is also including any x is greater than 1. So I go to 1, but it's greater than, not or equal to, and then I would go to the right where the numbers are greater. So it can be either or, and so you end up with the 2 separate arrows, and then I sometimes think of it, like I said, like the oars of a boat. Typically, they will go out from one another. So now we have a verb of solving, and so we're going to be doing solving and then also graphing. One thing to keep in mind that we learned in Algebra 1, but let's review real quickly. There's kind of a trick or a fact with solving inequalities that is not true with equations, and that is that if you multiply or divide by a negative, so if you multiply or divide by a negative number, you need to flip the sign. Or signs if it's a compound inequality, which we'll see. So here's my inequality. I'm going to treat it just like an equation. I like to get x to the left so that it looks like what we talked about up here. And so it's particularly in inequalities, I try to get the x on the left side if I'm solving. So in this case, I'm going to go ahead and do that by taking the 7x away to the other side, leaving me with negative 12x's plus this 2, and then I'll move the 2 over. So I have not done any multiplying or dividing. I'm going to do that now, and there's a couple things to be careful of. One, I am dividing by a negative, so I need to flip that sign over, and that's just something you have to remember to do. There's nothing that's going to make it obvious that it was wrong. So I'm flipping it into a less than, and then even though it's super easy to say this is 2, it's actually 1 over 2. It reduces to a half, and the negatives cancel one another out. So graphing this one's a little tricky, because if this is 0, a half is going to be right around here. Now it's or equals 2, so I'll go ahead and color that in. And then I need anything to the left or less than, because that's where the lower numbers would go. So when you solve, you end up with this, a statement regarding x's value, and then you go ahead and graph on the graph, clearly. Now this is a compound sentence, keep in mind. This one's an and sentence because it's between the two. You're going to solve this all at one time by focusing on getting this x alone that's in the middle. So I'm going to add 10, but whatever you do to the middle, you do to the other two parts of this inequality. So over here, oops, that's adding, sorry, I'll have a 6. In the middle, I'll have my negative 6x, but these cancel. And then on the right, I'm going to end up with 24. And now I'm going to go ahead and get the x alone by dividing by a negative 6, but you are dividing by a negative, and so you want to be careful again to remember that you're going to flip, and you don't just flip one of them, you're going to end up flipping all of them. So this end becomes a negative 1, this flips around, this is positive 1 because the negatives canceled, this flips around, and then 24 divided by 6 is negative 4. I like to write the statements in number line order, but you don't have to. Just keep in mind that when you go to graph this, this negative 4 is going to end up at negative 1, 2, 3, 4. It's or equal to, and then greater, so off to the right, because x is greater than, if you're looking at just this end that deals with the negative 4. But then on the other end, it goes to negative 1, which is not included because this one does not have the bar. So this is going to be open and this one's going to be closed. So the numbers actually end up kind of flip-flopped because you did flip those symbols around. But it is a between statement, and so you want everything in between. That way they will be less than the negative 1 and greater than the negative 4. They're in between. This is an or statement, so I'm going to go ahead and just solve each of them and graph them, thinking that most often, not every single time, I'll end up with two little ors going off to the side, like in a boat. So I go back to just my regular algebra skills, 5x minus 10. I add that 10 to both sides. I end up with 5x less than negative 2. And so I'm going to go ahead and divide by 5. Now, be careful. You're dividing by a positive 5. So just because there's a negative in the problem doesn't mean you have to flip it. You only flip if the thing you are dividing by, meaning the number on the bottom, is negative and my 5 is actually positive. So in this case, if this is my 0, negative 2/5 is going to be a hair off to here. And then I go ahead and I label it so it's clear what that's supposed to be. I left it open because it's less than but not or equal to, and then I'll have my arrow off here to the left where the lower than or less thans are. But that's only part of my problem because I have an or. So it can be there or it can be wherever this ends up. So let's go ahead and subtract 5 to both sides. And then I'm at this place, 9 minus 5 leaves me with 4. To get rid of 1 over 3, I'll multiply by 3 so that this cancels, and x will be greater than or equal to 12. Okay, so now I regret this because I'm going to have to go out pretty far. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to label it as 12. It's greater than or equal to, so I'm going to color it in and go. So both the red arrow and the blue arrow are a part of my actual graph. You're saying with an or statement, it's okay to be down here less than negative 2/5 or anywhere up here greater than or equal to 12. So that or includes all of those options. Here we're doing the opposite. They're giving us a graph and we're supposed to write the compound inequality. Oopsies. So let's do it. First of all, I see this and I go, oh, this is an and statement. This is a between statement. So I know that x will be between two numbers. And I know that on this end, the number will be a 4. And on this end, it'll be a -2. I also know that on this end, it's open. And then from there, going up to the right. So I'm going to have a greater than symbol. X, it's a little tricky because you read from the X. So even though you're like, that looks like a less than, you read it from the X, in which case I would be saying X is greater than -2. On the right end, this one's included. And so I'm going to end up with X is less than or equal to 4. In these between or and statements, the two symbols should face the same direction. Like the alligator mouth should be going to the right because that's where the bigger numbers on the number line are. And so my final statement is showing that X is in between 4 and -2 with the 4 end colored in because it was or equal. And then the -2 end is not colored in because it was not or equal to. Here I see two separate things. You can either be over here or over here. So I know my answer has to have the word or in it. It'll be a part of what I write as my answer because it is compound, but it's showing that it's an or statement. So let's figure this side out. Here my x's are to the left or lower than -15, which is actually colored in. So my x's are to the left or lower or equal to -15. Or over here, x's are going to the right or greater than, but not equal to 10 because that has the open circle rather than closed in. Everybody's favorite part is we are now going to write some inequalities and figure this out. So you have $125 in your lunch account. Each lunch costs $2.35. You're writing an inequality to model the possible number of lunches you can purchase. And then you're going to solve it to determine the possible number of lunches you can purchase. So X is representing the number of lunches, basically, that you have enough money to buy. So it's $2.35 per lunch, so times every lunch you buy. And you have to stay less than or equal to the money you have, which is $125 in your account. Okay, so there's not much to solving this. I'm simply going to divide both sides by $2.35. And I'm going to find out that my X value, meaning the number of lunches, has to stay less than or equal to 53.19. So you have enough dollars to buy 53 lunches, but not quite 54. So the total, like the max number of lunches you could have is you could have 53 lunches. After that, you would just have some change. You wouldn't have enough to purchase that 54th. Okay. Now you have $50 to spend at the fair, which is not enough money to bring to the fair, to be honest. You spend $13 for admission, and you want to play a game that costs $1.50 per time that you play it. It says write, solve, and graph an inequality to model the possible number of times you can play that game. Okay, so X is going to represent the number of times you play the game. Okay, so let's figure this out. You have $50 total, so you have to stay at or below $50. You need $13 to walk in the door. That's a flat fee, but then you also have $1.50 times however many times you play the game, and you need to stay at or below the money that you brought to the fair, which was $50. So that's my equation, and now I just solve it. I take away my 13, I have that $1.50 is less than or equal to 37. And when I divide by $1.50 on each side, I end up with x's being less than or equal to 24.6. So again, you don't have enough money to play the game a 25th time because you would run out of money. And so my answer is that you can play the game a max of 24 times. And there you have it, my friends. So this is all review, but that doesn't mean it's fresh in your mind. Some of the key things are just kind of keeping track of the and the betweens versus the ors and what those look like. That's going to be really essential as we make our way through the future lessons. And then also just kind of keeping in mind this fun fact that if you're working on an inequality and you have to divide by a negative or multiply by a negative, you will need to flip that symbol. So if it used to be greater than, it'll turn less than, and vice versa. Hope that helps. Bye.